Hello. Sorry if I'm a little late publishing this today, but I've gone through this 3 times and all 3 times it recorded badly. So we're going to try this one more time. So today we're going to look at the idea of limiting reagent. Now reagent is another word for reactant. Okay? So the idea here is that if you're given 2 reactants and they start to react, you might run out of one before you run out of the other. And once you run out of something, everything stops. So the one you run out of limits how much you can make. So here's an example that's not chemistry, but to show that you already have this concept down. You know how to do this. Okay? If you're given 15 bicycle frames and 26 tires, how many bicycles can you make? Well, if I use up all my frames, I can make 15 bikes. If I use up all my tires, I can make 13 bikes. Well, if I start assembling these bikes, once I get the 13th one built, I'll run out of tires and I'll be done making bicycles. So the most bikes I can make with these parts is 13 bicycles. Okay? If I want to make any more bicycles, I need more tires. More tires. So tires would be our limiting reagent. It limits how much we can make. And it limits it because you run out of it. Once you run out of it, everything stops. How many parts are left over? Well, if I used up all of my tires, I'd make 13 bikes, which means I'd use 13 frames. I started off with 15 frames, so 15 minus 13 is I have 2 frames left over. And that leftover stuff is something I have too much, something I have excess of. It is called the excess reagent. It's the one you have left over. It's the one that makes the most product. Okay? So, whole idea here is the limiting reagent determines how much product you make. Excess reagent doesn't change how much I make. If I gave you more frames, you couldn't make any more bikes. In order to make more bikes, you need more tires. Okay? So, how do you find out? Well, you saw the math for when it's bicycles. Now we're going to use that same math, but instead of being able to do math in our head, like if I use up all the tires, I'll make 13 bicycles. Instead, we're going to have to do stoichiometry problems. And we're going to do 2. One for if you run out of the first reactant, one for if you run out of the second reactant. And you turn them both into the same product, and the one that makes the least product is the limiting reagent. So, here's an example. If 10.6 grams of copper reacts with 3.83 grams of sulfur, how many grams of product will be formed? So I had copper reacting with sulfur, and it's going to make copper 1 sulfide. So and they told me about copper, and they told me about sulfur. They told me about both reactants, so I don't know which one I'm going to run out of. So first I take the grams of copper, and I'm going to turn that into products. So I take grams and change it into moles, using the 63.55 off the periodic table. Then take the moles of copper sulfide and change it into moles of copper and turn it into moles of copper sulfide. Change it into the product. And then take that moles of product and turn it into grams of product. Take the numbers off the periodic table. Copper 1 sulfide adds up to 159.16 grams. Pushing those numbers in my calculator gets me 13.3 grams of copper 1 sulfide. Is that how much I make? Maybe. That's if I run out of copper. What if I run out of sulfur? Well, I go through the same process. I take grams of sulfur, change it into moles of sulfur using the number off the periodic table. Take the moles of sulfur and change it into the same product. And then take the moles of copper 1 sulfide and change it into grams of copper 1 sulfide, just like above. And when I push those buttons, I get 19 grams of copper 1 sulfide. So if I run out of sulfur, I'll make 19 grams. If I run out of copper, I'll make 13.3 grams. How much am I going to make? Well, this is just like the bike problem. If I ran out of frames, I made 15 bikes. If I ran out of tires, I made 13 bikes. I'm only going to make 13 bikes because that's the smaller number. Because 13.3 is the smaller number, that's how much I'm going to get. Once I've made 13.3 grams, everything stops because I have run out of copper. Now, it might seem strange that you had to do 2 problems to get 1 answer, but actually got 2 answers because you also figured out that you're going to run out of copper. You figured out that copper is the limiting reagent. So you do 2 problems, you get 2 answers. Okay. How much excess reagent remains? So you use the limiting reagent to find out how much excess reagent you used. So I know that copper is my limiting reagent, so I'm going to take the 10.6 grams of copper. Take the grams of copper, change that into moles of copper. 1 mole is 63.55. Then take the moles of copper and change it into the excess reagent, the other reactant. So I'm going to turn it into moles of sulfur. And in my balanced equation, it was 1 and 1. Then I'll take the moles of sulfur and change it into grams of sulfur. 1 mole is 32.06 grams. So if I push those buttons, 10.6 divided by 63.55 times 32.06. Oops, sorry, wrong. I knew there's something else there. There was a 2 there. Forgot to divide by 2. And I get 2.67 grams of sulfur. The reason why I knew that I had done something wrong and I could check it right there, because my answer without that 2 came out bigger than the initial amount. Remember, I started with 3.83 grams of sulfur. This 2.67 is how much I used. So if I subtract those two, 1.16 grams of sulfur left over. And that's how much I have left over. So I take the reactant that I started with and ran out of, the limiting reagent, turn in the reagent I didn't run out of into the excess reagent, and then subtract that from how much I started with. What students want to do is they want to take these answers and subtract them. If I subtract these answers, I get 5.7, and what that 5.7 is how much copper sulfide I didn't make, which is not the definition of an excess reagent. An excess reagent, it's got to be a reactant, so it couldn't be copper 1 sulfide, and it's not how much I didn't use, it's how much I have, it's not how much I didn't make, it's how much I didn't use. Okay? So all the problems look like that. Now, they don't always take 3-step stoichiometry problems. You can do it just in moles. Here's an example where it's in moles. So magnesium reacts with HCl to make magnesium chloride and hydrogen. They told me about moles of magnesium, and they told me about moles of HCl. So they told me about both reactants. Okay? And they want to know what is the limiting reagent. So I start off with the 4.87 moles of magnesium and turn moles of magnesium into product. And they didn't tell me, they told me how many moles of gas, and H2 is the gas. So I'm going to change it to moles of H2. And in my equation, there's a 1 and a 1. Don't need a calculator for that. If I use up all my moles of magnesium, I will make 4.87 moles of hydrogen. And then I do the 9.84 moles of HCl. Turn the moles of HCl into into moles of the product. The product was H2. In my equation, there's a 2 and a 1, and that works out to be 4.94 moles of H2. Well, since 4.87 is smaller than 4.92, the answer is 4.87 moles of H2. That's how much gas I'm going to produce. What is the limiting reagent? Well, the limiting reagent is the stuff that makes the least, so the limiting reagent is the magnesium. I ran out of the magnesium, and that's why everything stopped. And how much excess remains? Well, I just said I ran out of the magnesium, so that's, once I say I ran out of it, once it's a limiting reagent, I always want to start with that because it controls this reaction. So I'm going to start with the 4.87 moles of magnesium. Get rid of moles of magnesium. Change it to moles of the other product, or other reactant, which was HCl. That was a 2 and a 1. And 2 times 9.8, 4.87 is 9.74 moles of HCl. And that's how much I used. And I started with 9.84 moles. And I used 9.74 moles. So I have 0.10 moles of HCl left. So you take the limiting reagent, turn it into the other reagent, the excess, figure out how much you used, subtract that from how much you started with. So it works in moles just as well as it works in grams. One more example. So if I put some aluminum into copper sulfate solution, get a single replacement, make my aluminum sulfate and copper. If 10.3 grams of aluminum and 51.7 grams of copper 2 sulfide are reacted, so they told me about both reactants. That tells me I have to do a limiting reagent problem. So I start off with the 10.3 grams of aluminum. Take the grams of aluminum, change it into moles of aluminum. 1 mole is 26.98 grams. Take the moles of aluminum, and they asked for copper, so I'm going to change it into moles of copper. And in my equation, that's a 3 and a 2. And then turn the moles of copper into grams of copper. And off the periodic table, 1 mole is 63.55 grams. Push those buttons, and I get 2.3 divided by 26.98 times 3 divided by 2 times 63.55 equals 36.4 grams of copper. That's if I run out of aluminum, but I don't know if I'm going to run out of aluminum. What if I run out of the copper 2 sulfate? So I can change grams of copper 2 sulfate to moles of copper 2 sulfate and figure out those grams. 63.55 for the copper plus 32.07 for the sulfur plus 4 times 16 is 64 for the oxygen. That's 159.62. I get rid of moles of copper 2 sulfate, change that into moles of copper, the product. That's a 3 and a 3. And then take those moles of copper and change it into grams of copper. 1 mole is 63.55 grams. Push those buttons on your calculator. 51.7 divided by 159.62. I'm not pushing times 3 divided by 3, but times 63.55 gets me 20.6 grams of copper. So if I run out of aluminum, I'll make 36.4. If I run out of copper or copper 2 sulfate, I'll make 20.6. 20.6 is smaller, so I'm going to get the 20.6 grams. Turn both reactants into products, whichever one's smaller, that's how much you're going to get. So in this case, the limiting reagent is the copper 2 sulfate. Okay, so of course, we're going to ask how much excess remains. So I know I'm going to run out of the copper 2 sulfate. I know it's the limiting reagent because I just did that math, so that's where I start my problem. 51.7 grams of copper 2 sulfate. Take the grams of copper 2 sulfate, change into moles of copper 2 sulfate. 1 mole is 159.62 grams. And take the moles of copper 2 sulfate and change into moles of the other reactant, aluminum. And there's a 2 in front of aluminum, a 3 in front of copper sulfate. Turn the moles of aluminum into grams of aluminum. 1 mole is 26.98 grams. Push those buttons, 51.7 divided by 159.62 times 2 divided by 3 times 26.98 equals 5.83 grams of aluminum. And that's grams of aluminum used. Since I started with 10.3 and I used 5.83, I find that I have 4.47 grams of aluminum left. Okay. So turn limiting reagent into excess and then subtract from how much you started with. These problems all work out the same, use the same techniques for all of them. Doesn't matter if it's in grams or liters or molecules even. Whichever makes the least of any one of those will make the least of all of them. Okay. So on School Loop, I have posted a worksheet. The front page of it is an example of how with tires and some more examples of problems. Then on the back, it's got all the questions. Work out those questions on your paper and give me pictures of your work to attach pictures of your work to the documents. The reason why I'm not going to have you put in the answers is because actually all the answers are there. I put in all the answers so you'll know whether you're doing them right or not. So now that you have the answers, I need pictures of your book. Don't forget that if you missed the quiz on the Friday before break, there's a makeup today from 1 to 5. And if you did take it and you want to improve your score, you're welcome to take that second quiz as well. Have a pleasant day.